nuclear chemistry, you're going to learn that nuclear chemistry is really easy, and you need to probably come by and get the little note page to go along with the PowerPoint, but you're going to get the short part of this. So we begin, the PowerPoint is over nuclear chemistry. And one of the things that you need to understand about nuclear chemistry is that it is completely different than what we've been doing. We've been doing chemical reactions, and chemical reactions all have to do with the electrons going around the nucleus. So we've been talking about the sharing or the transferring of those electrons. Nuclear chemistry, on the other hand, involves the actual nucleus, and so we're going to see something going on in the nucleus of the atom. And when you start talking about nuclear chemistry, we can't do that in the classroom. That's done on really, we're talking about nuclear bombs and nuclear reactors and stuff. You get large amounts of energy. So nuclear reactions produce over 1 million times more than a chemical. So this is a nuclear power plant here. So we won't be doing labs over nuclear chemistry. And so some of the terms that you need to know is what an isotope is, and an isotope has the same number of protons but different number of neutrons. So you have different forms of carbon, such as you have carbon 12 and carbon 14. Those are different forms. They all have 6 protons, making them carbon, but what's making them different is the fact they have different neutrons. If it is a radioactive element, then it's called a radioisotope, which means it has an unstable nucleus. So the term nucleon is the term that we use when we talk about protons and neutrons together. Again, if you have the little worksheet, this little PowerPoint is going right with that worksheet. These are 3 different isotopes that you're looking at. A hydrogen, the very first one, has 1 proton, it has no neutrons, and this is its mass number here, and this is its atomic number. So 11H is regular hydrogen. That's where we find most of our hydrogen in the world. This one, it has 1 proton and 1 neutron, which has a mass number of 2. That's again what the top number is mass number, which is protons plus neutrons. It has an atomic number of 1. This is called deuterium. It's a type of hydrogen. And then another type of hydrogen is called tritium, and that has 1 proton, it has 2 neutrons, so therefore it's going to have a mass of 3, again 1 for the atomic number. So these are all isotopes of hydrogen. This one right here is actually not radioactive. These 2 actually are radioactive forms of hydrogen. So radioisotope means that the nucleus, for whatever reason, is unstable. And a lot of times the instability has to do with the fact that it's got maybe too many protons or maybe too many neutrons, and the ratio is not quite right. Elements like to have what we call an NP ratio, usually around 1, same number of neutrons and same number of protons to make it stable, especially the first 20 elements on the periodic table. The first 20 elements, the smaller atoms, like the same number of protons and the same number of neutrons. And so when you start getting heavier elements, they don't necessarily have a 1-to-1 ratio. But what happens if they become nuclear unstable, they do something called nuclear decay. And nuclear decay is when an unstable atom will emit something, become a different atom, and it will become stable. This right here is just a chart just showing you. The green is the NP ratio. This is when they have the same number. And you can see these lower ones are very, very stable when they have the same number of protons, same number of neutrons. But as they get to be larger, the red is called the stability. This is how they're more stable. And so they don't necessarily like 1-to-1. They actually like more protons than neutrons when they get to be larger atoms. And so there are types of emission. We're only going to do 4 types. Next year we'll pick up the 5th type. But the 4 basic type that we're going to do is alpha, beta minus, beta positive, and then we're going to talk about gamma. So we're going to spend our time on those. And again, this PowerPoint is uploaded, so you can download this PowerPoint. So if I go too fast, you can always pause and stop, etc. And this year we're not going to do K-capture, but next year we will do K-capture. The very first one is called a beta minus, and its symbol is 0, -1e. So this is the symbol you need to know for beta minus. It has a charge of -1. This bottom here is the charge. It has a mass of 0. That top number is the 0, is its mass. It has a penetrating power of 100 times more stronger than an alpha particle. And A beta particle, you can block it by putting like a piece of aluminum foil between you, but it can still go through your skin if you don't have something to protect yourself from a beta particle. This is what they think happens and why they think happens. They think that the NP ratio is too high, meaning it's more than 1, so it's got more neutrons than it does protons. And so what scientists think happens is that they think that a neutron actually splits up. This is what's happening. They think a neutron here, which looks like this, splits into a proton, and then this beta minus particle is actually shot out of the atom. You do need to know this for your quiz. You need to know what the scientists think. And again, they think, for whatever reason, they think a neutron actually breaks down into a proton, and then this electron is actually shot out of the nucleus. And normally electrons are not in the nucleus, so this is kind of different. It gets completely shot out of the nucleus and out of the whole atom. Again, you need to know why it happens and what scientists think happens for a beta decay. So here's an example, and I'm actually going to go to a blank page and show you this example, which will hopefully make a little bit more sense, and then we'll come back to the PowerPoint. We'll go to a blank piece of paper, and we're going to just show you what they think a beta decay happens. This one is called carbon-14, which is definitely radioactive. This is the mass number, which is the protons plus the neutrons. This is the number of protons. So if I wanted to figure out the NP ratio, how many neutrons to protons it has, the bottom number is the atomic number, which is number of protons. I'm just going to come over here. This has 6 protons, because that's the atomic number. To figure out the number of neutrons, I'm simply going to subtract these two numbers. So 14 minus 6 is going to get us 8. So the reason this is unstable or radioactive, it's got more neutrons than it does protons, which makes the nucleus a little unstable. So what they think happens is that one of these neutrons, again, breaks down into a proton, and this mysterious beta minus particle, this particle here, is actually shot out of the atom. And we can measure that with something like a Geiger counter. So you can see that the proton, this is going to break down, disappears. So this number is going to actually go to 7, and this proton stays, so this is going to be 7. So you're going to see the mass change, and you're going to see the atomic number change. So the way we write this, my pen catch up here, is we know it's going to be, again, a beta minus because it's got more neutrons. So we write it as a beta minus. And the top numbers have to equal. So this is 14, so you've got the top number, this is like an equal sign in between here. So this is 14, top number is 14, so 0 plus what would make 14, so that's going to be a 14. This is a negative 1, and this side over here is a 6. So this side is 6, so this side over here needs to equal 6. So negative 1 plus 7 would actually equal 6. And then I would go to my periodic table and I would look up number 7, and you will find that it's nitrogen. So what this means is carbon-14 actually breaks down and forms nitrogen-7. And we do know that that is what happens to carbon-14. This over here is known as the parent. This here is known as the daughter. So you got the parent over here on the left of the arrow, and the daughter is on the right. This right here is known as the emission. Okay, so again, parent. So if you're looking for the parent, you're looking for the left. The emission and the daughter are always going to be on the right side of the arrow. This is called a beta minus. The next type, let me go back to the PowerPoint. See, this is what's happening. And it says the atomic number is increased by 1. See, here's our atomic number. It went up by 1. The mass number stayed the same. The subscripts and superscripts are equal on both sides of the arrow. So that's what was going on. The NP ratio is changed. So here's what's happening. It changed, and that beta minus particle is shot out. That is a beta minus decay. And it happens because you have too many neutrons, more neutrons than you do protons. Then we have like the opposite of that, which is known as a beta positive decay. This is also known as a positron, like a positive electron, positron. Its symbol is 0 plus 1 e. Its charge is a plus 1, its mass is a 0, and it also has a penetrating power of 100 times. What they think happens with this, or why it happens first, is that your NP ratio is too low. What that means is you have more protons than you do neutrons. And what the scientists think happens, and you do need to know this, you need to know what the scientists think happens. They think because it has too many protons, that one of the protons from the middle of the nucleus actually splits into this mysterious neutron, and this beta positive particle is actually shot out of the atom. So this time, instead of a neutron breaking down, it's a proton breaking down into a neutron and a beta positive particle. Again, you do need to know that for your quiz. And here's an example, and I'm going to go to a blank page again, just where I can work it with you. If we had, this is called carbon-10. Again, first thing we would want to do is come over to the side and figure out the NP ratio. There are 6 protons. That's coming from this number. Again, this one's protons plus neutrons, so I subtract these two, and you'll find that it has 4 neutrons. So you can see that you have more protons. So what's going to happen is one of those protons is going to break up. It's going to emit, here's our emission, a beta positive because it has more positives. And it's going to then change. Again, the tops have to equal, so that's 10. 0 plus 10. Tops are going to equal, and this equals 6, so 1 plus 5. And then I go to the periodic table and I would find number 5, and it's boron. So carbon-10, the parent carbon-10 does an alpha positive, or a beta positive, or also known as a positron emission. And then this is the new daughter that forms. Boron-10 is the new daughter. This is a beta positive positron. It happens when you have more protons. Okay, and that's again what all that is saying there. Our last type of emission, as far as writing our equations are concerned, is an alpha particle. And what an alpha particle symbol is 42He. Basically, it's a helium atom. It doesn't have any electrons, so it's just 2 protons and 2 electrons. So they just call it a helium atom. But really, honestly, it's not a true helium atom. It's 2 and 2, 2 protons and 2 electrons. Its charge is +2, getting that from the bottom. Its mass is a 4, coming from the top there. It has a penetrating power of only 1. It's actually, because it's such a large particle, you could block an alpha particle by just putting a piece of paper between you and an alpha particle. The reason it undergoes alpha decay is like the atom has gotten too fat, and because protons are positive, you get too many of those positive things in the nucleus, they start repelling one another, and they'll start shooting off 2 protons and 2 neutrons in order to get back to the stability point. So anything with the atomic number 84 or up is going to do an alpha, and that's the atomic number, meaning the bottom number. And the reason, again, is they think there's too many protons and they start to repel each other. That's what they think that's going on. So here's what this would look like. 23892U, that's a uranium. We know it's going to do alpha because this number right here is 84 or above. So we would predict alpha. Here's our emission. Our tops have to equal, so 4 plus something made the 238, and that's where 234. 234 plus 4 make the 238. Notice we always have 2 things on the right and only 1 thing on the left for these emissions as far as these are concerned. And it's 42He, so this is 2, so this is 92, so that's where the 90 came from. And then we look up 90 on the periodic table, and that made thorium. And so here's what's happening. It's giving off that alpha particle. Notice the atomic number of the daughter is 2 less, and that the mass number is actually 4 less. So this is our daughter. This one's actually not stable either. See, notice it's 90, so it would probably emit another alpha. They do more than 1 emission, but I'm just having you guys do one. It may do like 4 or 5 alphas and then a couple of betas. We're just doing 1 emission, the main emission. Again, it's going to be beta minus if you have more neutrons, beta positive if you have more protons, and the easy ones to find is going to be the alpha, because that's going to have an atomic number of 84 or above. So those are the 3 that we're going to be using on the worksheet. So if you need to do the worksheet, you need to come by and get a worksheet from me. This is just showing those from 84 or above are going to be emitting an alpha in order to become stable. The last type of decay it has the symbol of Y. It's called a gamma, and it's actually an electromagnetic wave. And so we won't be writing them in our equation, but a lot of times it's given off as a byproduct when the other things are given off. So it may give off an alpha and a gamma. But what I want you to know that it has no charge. It has no mass, so therefore that's why we don't write it in the equation, because it doesn't change the element, but it's energy that's given off. And I want you to know that it has a penetrating power of 10,000. So it's the one that causes the cancer, the gamma radiation that's given off during nuclear decay. And so it's what can hurt you. So that's the main thing I want you to know about gamma. It's a high electromagnetic, causes damage to your tissues, no change in the numbers. Here's some examples. Alpha cannot penetrate the skin and can be blocked out by a sheet of paper, but is dangerous to the lungs. Beta can penetrate the body, but can be blocked out by a sheet of aluminum foil. So it's strong, but not that strong. Gamma, on the other hand, can go right through the body and requires several centimeters of lead or concrete or even a meter of water or so to block it out. So this gives you a little idea. See, the gamma is so small that it can go right through. Beta a little bit bigger, so it can go through this but can't go through that. And alpha is kind of fat, and it can't even go through a sheet of paper. So that just gives you an idea. So you're going to be working on those equations. Again, not hard at all. So that's the rest. That's the end. We're not going to do Cape capture, so I'm just going to keep clicking through this. I'll do Cape capture next year. I just don't want to confuse you right here before tax. So that worksheet should be extremely easy. We're going to stop this PowerPoint now. Well, that is all that. And that's all you missed. You need to take this quiz. Very, very easy to do, so not a problem. So if you need help, please come in and see me. I don't know where the stop button on this is, or